Hi, I'm Dan.
Dan the science man.
Hey kids, today we're going to talk about the atom and two scientists named Heisenberg and Schrödinger who contributed to the modern day version of the atom. First we're going to talk about quantum physics and how Schrödinger contributed to the knowledge of quantum physics with his cat model. But first we need a cat, and better yet, we need two assistants with a cat. So here we go, we got Emily and Rachel with my little cat Nina. So think about this.
Cat's in a box right now with a can of poisonous sardines. It can either eat the sardines and die, or not eat the sardines and live. Quantum physics says both are happening at the same time. So right now, the cat is both dead and alive. What a crazy world quantum physics is.
So, Schrödinger's thought experiment on the now dead or alive cat kind of shows his cloud theory. What his cloud theory says is that a subatomic particle is everywhere and nowhere at the same time. Basically, a subatomic particle is moving so fast that it's covering so much space that you never know its location, and when you say it's at this location at one moment, it's actually not there, but it's at another location. Crazy, right? But truthfully, it's just like a cloud. It covers a lot of space in a certain area, but you never know where it is.
So Mr. Heisenberg created this theory, or this principle I guess you could call it. It's called the principle of uncertainty. And what it says is that in a subatomic particle in an atom, you can never tell both the location and the momentum of a subatomic particle in an atom at the same time. We're going to demonstrate this through one of my assistants, Rachel, running back and forth, looking like a fool, but really demonstrating what the principle of uncertainty is all about. So the first part Rachel's going to show you is how you can tell the momentum of a subatomic particle, but you couldn't tell the location. As you can see, Rachel is moving. You can see her moving and you can see how fast she's going. But you can't tell the location because she keeps on going and you don't know where she is. Now the second part of the principle of uncertainty is that you can tell the location of a subatomic particle, but you couldn't tell its momentum. So as you can see, Rachel is running, but she stops. So you can tell her location where she is, but you cannot tell her momentum because she's not moving anymore. So basically, Schrödinger and Heisenberg really helped each other out. Schrödinger said, well, we can only tell the momentum, but we can't tell the location of a subatomic particle. But Heisenberg's like, no way, man. We can tell both the location and the momentum, but we can't tell them at the same time. So they both helped each other out. And so that's how eventually the modern model of the atom came to be. So, just to sum up what we talked about today, you know, we got scientist Schrödinger, who was like this super awesome guy who, you know, kind of really showed us what quantum physics was all about. I mean, you know, we talked about the... We never checked on the cat. Did you guys check on the cat? Well, we learned about like the cat and how it could still either be dead or alive right now. And it's actually both right now. And we learned, you know, how that applied to his cloud theory that subatomic particles are everywhere and nowhere at the same time. Then we got Heisenberg, who was like, yeah, I'm going to take your idea, Schrödinger, but I'm going to add to it with the principle of uncertainty, which says, you know, we can tell the location but not the momentum, and we can tell the momentum but not the location. So basically we can't tell momentum or location at the same time of a subatomic particle. Man, that's a mouthful. And that really just related to his modern model of what an atom is. And so I hope you guys really enjoyed it, and I know I did, and I'll talk to you guys later.